Hello everyone and welcome to the next session of Core Java. In continuation with collection framework, in this session, we will discuss about list implementations. First of all, let's have a quick overview of what collection framework we have in Java. So these classes and interfaces which are part of collection framework are available in java.util package. So the hierarchy begins with this collection interface, and whatever you can see over here in these angular brackets, which is specified as E, that is nothing but what type of element will be stored in that particular collection object, which is specified by generics. So this is nothing but representation of generics. So collection is the interface. It is extended by three other interfaces as list, set, and queue. List has got its own implementations like array list, linked list, stack, vector. So these are list implementation. Set as has set, linked has set, tree set. Queue as priority queue, array queue, and linked list. That is nothing but DQ. These are other what we can say interfaces, right? So navigable set, extends sorted set, extends set. Now, what is this list and set? These two are going to hold objects. However, there is a difference in list and set. List is ordered, indexed implementation. Set is unordered or non-indexed implementation. List allows duplication of data. Set does not allow duplication of data. So depending on how you want to store data, you can choose either list implementation or set implementation. Queue, again, we are going to store objects, and through operation, we are going to access the data members. So we will discuss about this queue in detail later on. One more hierarchy of implementation in collection framework, which is map. In list and set, what happens is we are just going to store the objects. They are not going to have any unique identification. So if you need any unique identification for every value which is available or which is being stored in a collection, then you can make use of map hierarchy. So the hierarchy begins with map interface. These are certain implementations as hash map, hash linked map, hash table, and tree map. So this is overall, or we can say that this is just an overview of collection framework which is available in java.util package. We are going to understand these hierarchies in detail. So let's begin with the list implementations. So as I have already mentioned, lists are ordered or indexed. Duplication is allowed in list, and various implementations like array list, linked list, vector, etc. Where array list is again indexed implementation. It is just a dynamic array. Index starts with 0 and consecutive memory locations will be allocated for array list as we go on adding the elements. Now in collection, what we have is we are going to create an object of a specific collection object type, class type, and that object is capable of storing multiple elements. And whenever we are performing this operation, it can be stored in multiple ways. So one approach is array-like implementation using array list. Now collection has one more feature we will say, or characteristics we will say, as whenever we go on adding the elements, the size of the collection keeps on growing. It is able to accommodate more and more objects, which is not possible with arrays. Also, if we are deleting elements from the collection, that collection will be shrinked. So it will remove the element and size will be decreased. So this dynamic effect is available in any collection implementation. So array list is dynamic array with increase in the size or shrink in the size as we go on adding or removing the elements. Linked list. It is a linked list data structure implementation where the current object holds its own value and the reference to the next element. And the third implementation is vector. However, vector is a legacy class which was already there in Java even before collection framework was introduced in JDK 1.2. Vector class is there available in Java even before the collection framework was introduced. It was capable of storing multiple objects at the same time, and when collection framework was introduced, vector became part of this collection framework. Now, how this hierarchy is followed: array list is the class which is implementing list interface, and list interface extends collection interface. So this is the hierarchy. Now we are going to have a look at how array list works on the data. So whenever we want to create object, so we will import list. We need to make sure that you are importing correct list. We want this list interface to be imported from java.util. Here we will specify what type of object being stored. So here I have not specified int, I have specified integer. So list equal to, this is the object of array list class. Then to add elements, we have add method. We can now directly store data. Internally, it will convert it into integer object, which is achieved through autoboxing. We have already discussed about autoboxing earlier. Now, to begin with, if you want to check what is the size of this particular array list, so we have a method list dot size. I will just copy this over here again. So just to check the whether the size of the array list is being increased as we go on adding the elements. So whenever now I am executing this particular code, you can see that initially the size was 0 and then the size is increased to 2 when we have added 2 elements. As we go on adding more elements, say I am adding same element because we need to check the duplication as well. Add again 23. So now what I will do, I will print the list itself. So let's see if we can have this particular list displayed. You can see that list is displayed and 23 is displayed thrice. So duplication is allowed. So this is adding the elements. Also, you can see that whenever we are adding the elements, they are getting added in a ordered manner. So you can see that in any situation, the order is maintained. In whatever order you have entered the data, same order is maintained while producing the output. So add is going to add the element at the end of the existing list. There is one more add method, which is overloaded method. And say for example, element is 100, and I'm printing this particular list again. Yeah. So this 100 is being added. Now what is difference in this add method and this overloaded add method is this add method is going to add this particular element at the end of the existing list. This add method accepts two parameters. First is the index and another is the actual value. So this add method actually works as insert operation. So whenever you need to insert data in between, you can make use of this particular add method. Suppose I want to remove any element. So I have a method remove, and it will take the index, and again we can print this particular list, and also I will print the size, because we need to check the behavior as whether the size is decreased or not. Yes. So here you can see that initially size was 0. This is insert operation. This 45 is removed and size is reduced to 4, because 1, 2, 3, 4, 5. 5 was the size. After removal of first element or one element, the size is now reduced to 4. So it is reduced by 1. Now we will see search operation. How can we perform search operation on it? Equal to false. So this is some flag, we will say, or a boolean variable which I have declared, right? And initially it is false if list dot contains certain object I want to search, like say for example 12. Is available equal to 2. So if that particular value which I am specifying is available, that flag will be set to true, else it is false. So if is available means if is available is true, element is found, else element is not. Now this can also be implemented in one statement. All this can be implemented in one statement in this way, equal to. So depending on your requirement, you can do that. So whether you are getting the value directly or what logic you want to implement, because one application can be implemented in different ways. So I'm executing this particular code. So you can see that it says element is found. If I'm specifying a value which does not exist, then it says element is not found. So this is about the contains operation. Now we will see how can we iterate over all these implementations. So there are actually multiple ways how can we iterate over a list. The very first approach is using for loop, and here this I variable will be used as index for this list. So list dot size, and we will use list dot get is the method to retrieve the variable at a specific index. So this is iteration can be done. So it is iterating over it. So this is using for loop. Another approach to iterate over actually indexed as well as non-indexed implementation is for each loop. So we can make use of for each loop as well. So this is some variable adds value, and I'm directly printing this value over here. So it will give you the same output, no doubt about it. How is the approach? Whether you are executing or iterating over a list using index or directly the value. So this is one more approach how we can iterate over it. And third one is by using iterator, where iterator is an interface which allows us to iterate over any collection implementation. So first we will convert this list into iterator. Then in iterator, there is a method, say has next. So if there is next element, this has next method returns a boolean value, yes or no, true or false. If yes, continue. If no, don't execute this particular code. So system.out.println itr dot next. Next method returns the next available value. So has next is going to check whether the value is available. If yes, it will execute this particular loop, and itr.next is going to fetch the next available value. So while iterating over this, you can make use of either for loop, output will be same. You can make use of either for loop or for each loop or iterator, out of which for loop is applicable only for the indexed implementations. However, for each and iterator are applicable for indexed as well as non-indexed implementations. So this is about the lists. You can refer to documentation and check more methods which are available, and then further implement the code. Thank you.